All right, related rate problems are going to vary depending on the problem. So we have to write an equation, differentiate it, and then substitute the information we want. So let's look here. We have a wall and a 13-foot ladder. And we have that the base is being pulled away, dx dt is being pulled away at a rate of 1 meter per second. And we want to know how fast this top part is going down. That's what we're looking for. All right, so we know x squared plus y squared equals 13 squared. And so that's our related rate. So now what we're going to do is actually take derivatives. That's the related rate equation. So 2x dx plus 2y dy equals 0. And we want to solve for dt, so we divide everything by dt. And we want 2y dy dt equals negative 2x dx dt. And now we're going to divide by 2y. And those cancel. And now we have to figure out our x and y value. Well, it's not going to be too difficult because we know that we're talking about when x equals 5. That's what we're looking at solving. So what's our y value? So 5 squared plus y squared equals 13 squared. Y squared equals 169 minus 25. And y squared ends up being 144. We do not care about the negative since there's never a negative length. And so we're looking at when y is 12 meters and x is 13 meters, what does this rate become? So let's see what we get. We plug in 5 and we plug in 12 and we multiply it by 1. And so what we end up with is dy dt equals negative 5/12 meters per second. That's the rate that this ladder is falling down the wall. All right, a 6-foot-tall man is walking straight away, here he is, from a 15-foot. So this is 6 foot, this is 15-foot street light. At what rate is his shadow lengthening? So we want dl dt. That's what we're looking for. dl dt equals what? When he is 20 feet away, so when x equals 20 feet away from the street light, if he's walking at a rate, and the rate that he is walking is 4 feet per second. Okay? And so now what we have to do is come up with a related rate equation. Well, it looks like to me I have proportional triangles. So I've got this one, 6 is to L, as 15 is to L plus X. So what I'm going to say is 6 is to L, as 15 is to L plus X, cross multiply. And then we have 9L equals 6X. It doesn't matter which one we start off with. We could do the L equals 6 over 9X, or we could solve for X. It does not matter. And let's reduce. So now we have 2/3 X. That is our related equation. Now we're going to take derivatives. dl is to 2/3 dx. We divide everything by dt. And this is what we're looking for. So now we have 2/3. This, he moves at a rate of 4 feet per second. And we end up with 8/3 feet per second is how fast his shadow is lengthening when he is 20 feet away. All right, here is a typical cone problem. We have a cone that has a height of 9 centimeters, a diameter of 6 centimeters, and the water is leaking at a rate. Now, as soon as I see cubic centimeters, that tells me that it is leaking, it is leaving the cone at a -1 cubic centimeters per minute. Find the rate at which the height is dropping. So we're looking at dH dt when h equals 3. That's what we're looking for. I have to find a related equation. I'm talking volume. Well, volume is 1/3 pi r squared h. Well, I don't want to have to do the product rule, and I don't have any information related to how the radius is changing, so I'm going to try and relate the radius before I do anything else. So I have, this is 3, and this is 9, this is my r, and this part here is my h. So with proportional triangles, I could say 3 is to 9 as r is to h. Solve for r, so I get 3h over 9. So r is 1/3 h. Now before I do anything else, I'm going to substitute 1/3 pi h over 3 squared times h and simplify. So now I have pi over 27h cubed. This is now my related equation. I'm going to bring it over here, and what I'm going to do now is I'm going to take differentials. How do I do that? Well, let's see. dv equals, this is a constant, times 3h squared dh. Divide everything by dt. Now I want to solve for dh, so I've got dv dt equals 27 divided by 3 pi h squared, or times, equals dh dt. I'm solving for dh dt. So this is going to get flipped when I bring it over to the other side. Now my h happens to be 3. So what I'm going to do is I've got dv equals -1 times 27 over 3 pi 3 squared equals dh dt. Well, 27 goes away and we end up with -1 over pi. And you could change that to a decimal, but that is centimeters per second. It's negative because the height is dropping.